So this is lecture 4. So in last 3 lectures we have discussed what are the different types of feedbacks, and also we discussed in detail the closed loop control system, the effect of feedbacks in closed loop control system. So that we have discussed, that is the closed loop control system. So let us first draw it. So that is, we give one reference command R here, and this is that controller, and the control input is fed to the plant. So this is that plant, and we take feedback here. So this output, this is called that controlled output, and here this is that control input, and E is that error signal. So suppose we are taking that negative feedback. So here that error signal E, that equal to R minus Y. So the idea of feedback, to make corrective actions, so these corrective actions means, here this corrective actions is basically this U, that control input, the output of that controller, based on the difference between the desired and the actual values. So here you can see the difference between the desired and actual values. So here R is actually the desired values and Y is that controlled output. So this difference means here actually that error signal, the difference between the desired and the actual values, that is that error signal of a quantity can be obtained in different ways. So that means the control input that you will be generating, it can be done in different ways, and today we will be discussing two types of control. One is that on-off control, and other one is PID control. So this PID stands for proportional derivative, proportional integral and derivative. Integral and derivative. So this particular control input controller is widely used in industry and everywhere, and also this on-off control, this is the simplest form of feedback control which has many applications, like that in refrigerator, in air conditioner. So everywhere we use this on-off control. So today we'll be discussing in detail, that means how that on-off control works. So let us start this on-off control strategy. So here you can see that reference command we have given, and we want that control output should track that reference command. So then an error signal is generated. So this error signal is actually the difference between that R and Y. So now this on-off control strategy is as follows. So let us first just draw only that part, that comparator part. That means here we have that positive, this is the command signal. We have that command signal, and here we have that controlled variable, that is that Y. So here you have that Y, and we are using negative feedback. So here you have that E, which is actually that error signal. So now we have that controller, which is on-off controller. Now depending on this particular error signal, that on-off controller generates some control input, that is U, which is actually that, this U is actually that corrective actions, which is fed to the plant. So now what is that control law? This control law is the simplest one. This is the simplest form of control law, that is U equal to U max whenever error equal to is positive. That means error is greater than 0, and this is equal to U min if error is less than 0. So this is the simplest form of controller, and here you can see this error signal E equal to R minus Y, that we have already discussed. So now just from this particular structure we can understand that this is that the control strategy is very simple. So this is a simple form of controller, and we have not chosen any parameter to get this control output. This control output U depends only on the error signal E. So no parameter to choose. So that means to generate this control input, we need not to choose any parameter, because it only depends on the error signals. When error equal is positive, then U equal to U max, and when error is negative, then U equal to U min. And it has some disadvantages as well. So one disadvantage is typically it results in oscillation of controlled variable. So this is obvious. The reason is whenever error is changing, once it is becoming positive and again it is becoming negative, so U is changing from U max to U min, U max and U min, and there is a discrete jump. So there is an oscillation in controlled variable. So this is actually one of the disadvantages of on-off control. The reason is, if we are interested in to get a smooth output from on-off control, we cannot have it. So how it looks like? So suppose this is the t-axis, and here you have that control variable yt, and suppose you have set that reference command r here. So now whenever that output is increasing like this, suppose that output is increasing like that, and whenever this y crosses that r, so that then you can see here, from here, whenever y is greater than this r, then obviously that error signal becomes negative, and whenever error signal is negative, u equal to u mean. So immediately you can see that, so that u mean, if it is equal to suppose 0, suppose u mean equal to 0, so that means whenever that y crosses that r, when this y crosses that r, so if u mean equal to 0, so that means there is no control input, that means it is in off stage. So whenever it is off, then immediately it starts falling down, and when again y crosses that r, that means error is positive, then again it is on. So like this, that means the output, there will be some oscillation because of that on-off structure of that controller. But this particular control strategy is very much effective. As I have pointed out, this control is used in many cases in industry anywhere. Like for example, this on-off control is used in refrigerator as well as air conditioner. So you can find many examples where this on-off control strategy is used. So there is another disadvantages of this on-off control, although it is simple, that is control variable, because you can see here, whenever that error equal to 0, when error equal to 0, so no control input is defined. So you do not know what would be the control input, how much input will be fed to the plant, how much control input will be fed to the plant, you do not know. So this is one of the disadvantages of this control strategy, but as it is very simple, it is also an effective control algorithms. So one thing is that control variable is not defined when the error is 0. So to overcome these advantages, some other control techniques are also used. So here I am just showing, that means how that on-off control works. So this is that error signal. So, and this is that u. Whenever error is positive, then you have some value, that is u max, and whenever error is negative, then you have u min. So when error is negative, then that control input equal to u min, and when error is positive, then control input equal to u max. But you do not know at this particular point, that means when error equal to 0, what value you have to take. So this is actually that on-off control strategy. So similar to on-off control, there are also some other strategies like that, very similar to this. Another one is called the dead zone. So this is error. So in this case, what happens? So this is that control input u. So whenever error equal to 0 or error equal to 0 or error is positive, that means suppose this value is E max and here this value is E min. So that means when error is inside that band, so this band is this one, then there is no control input. So in this particular band, that error control input equal to 0. So when error in between E max to E min, then control input equal to 0. So this particular zone is called that dead zone. So this is called dead zone controller. So that means we are allowing some dead zone here when there is no control input U0, but when error greater than E max, then immediately we apply U max. Similarly, when error less than E min, then we apply U min. So that means the difference with this dead zone and on-off control is that in case of dead zone, we just allow one zone, allow a band. Whenever that error lies inside that band, then control input is equal to 0. So this is also another type of control strategy we apply in practical applications, and the name of this one is dead zone control. Sometimes we also use another type of control strategy that is called that hysteresis control. So in that case, we just keep some overlap. So the overlap is like that. So suppose you have started from here, say suppose error is increasing positive, so then it is 0, and whenever error is coming say E max, then suddenly it jumps to this value, and suppose error is increasing, it is going like this. But what happens whenever error is decreasing, suppose error is decreasing, so then it follows this path. Instead of jumping here, it follows this path. And then whenever error equal to say E min here, then it jumps from this point to that point. Then again suppose